Welcome to Chapter 8, last chapter, guys. Before we get started on 8.1, I'd like to point out some stuff that we're not going to do because I think it's really important. You have access to this textbook for a while, so it's got so much really good information in it. Look at 8.2, we're not covering it. And laws change every year or so, but the basics stay the same. And 8.2 covers income taxes in a way that really makes sense. This author is very good at explaining things in a way that anybody can understand. So, as you're making your way through life, and a lot of you are really young, you can start now and really have a positive effect on your financial future in a much easier way than those of us who have spent some years maybe messing up a little bit. 8.5 is all about investing, making your money work for you. We'll talk a little bit about that in the 3 sections that we are going to cover. 8.6 is buying a car, what to look for, what not to get mixed up in, things like that, how the financing works. Huge one. 8.7 is about the cost of home ownership. There's more to it than just mortgages, but it may pay off for you guys to, I spelled that wrong, may pay off for you guys to read that and see what's up. Most of you are far away from being ready to do that, but it's good to have a leg up and know what you're getting into, know what you need to be saving for in the future. And financing a home is not really, you shouldn't consider that the same way you would debt on a credit card or a car payment, because it is a huge investment. Speaking of credit cards, please, if this is the only thing that you look up, look at the section on credit cards, because holy cow, don't get in trouble, okay? That's some really good information that will really pay off a lot if you pay attention to it now while you're young. Okay, now 8.1 is basic stuff. Most of it you probably already know. We start out with what percents, how they relate to decimals and things like that. So with the word percent, first off, the per always means divide. There's 100 cents and a dollar. So when you see this symbol, whatever number in front of it has been divided by 100. So 85%, you take that decimal right there, you've got to divide by 100, which moves it over 2 spaces. So if you start with the decimal, you're making this number bigger by 2 decimal places and then putting the symbol. If the symbol is there and you want to go to the value that you're going to use in your calculations, you're going to take this decimal and make the number smaller by 2 decimal places. And it may be good to think of decimal 8.5 as 8.5 divided by a 1 and the 2 zeros, because there's 2 decimal places there behind the decimal. So you see divided by 100, there's your percent sign right there. So to change from a decimal to a percent, you're going to make the number bigger by 100. To change from a percent to a decimal, you're going to make the number smaller by two decimal places. And if you forget, you can always remember, we all know that 50% is a half, and a half is 0.5, which is 0.50. You see what I mean? Make that number bigger by 2 decimal places and put your symbol, and you get 50%. Okay? And always ask yourself, should I make the number bigger or should I make the number smaller? Okay. The author makes a point of specifying the difference between something like the sales tax and the sales tax rate, or the discount and the discount rate. So pay attention to what the questions are asking in the homework. The sales tax is the actual amount of money that gets added, okay? Whereas the sales tax rate is the percentage that you're of the price that is going to be added as tax. So the total cost of an item will be the price plus the sales tax. And the sales tax, always remember this beautiful thing, um, sorry, rate times amount. That's the key. And percents are rates. And you're going to have to really grab on and take a hold of the concept of rate times amount in this chapter. And you're also going to have your calculator handy. Make sure you know how to use it. I can't teach you that because I'm not with you. And even if I was, everybody's calculator is different. So you're going to have to learn to use, this is a caret key. You use that to raise something to an exponent. Some of you with a TI, it may have a y to the x key. You're also going to have to look for, in the last section, you're going to have to look for a key that says ln, because above it you have e to the x. And the e to the x key is what we're going to be using in section 3 along with those other exponent keys. So focus on the fact that the sales tax is the money that gets added, this bit, which is found by multiplying the rate times the amount or the cost of the item. And then you always add that tax back to the price to get your total cost. Okay, let's say that the jeans are $31 and your sales tax rate is 6%. I have no idea what our sales tax here is in Virginia. I know it's pretty high for things like restaurants and stuff, but I'm not sure about whatever. This is good enough. So your total cost of the jeans is the price of the jeans plus the tax, and it's the rate, tax rate, times the cost of the item or the price of the item. When you multiply this, notice that it said 6%, but we divided by 100 before we use it in a calculation. Never multiply by plain old 6 if there's a symbol. Don't forget you have to move your decimal. Okay, so this right here, that's my tax. This is the tax rate, and this is the tax. You add the tax to the price of the item, and you get the total cost of the item. Okay, discounts work the same way as sales tax did, except you know you're going to pay the sales tax, so you knew you were going to add to the price of the item. Whereas for a discount, you know that's going to be subtracted because it's, it's what you get off. You know that. So remember, the discount is the actual money that you're saving, whereas the discount rate is the percent that you're taking off. And I see a mistake. I can't spell. So discount. There we go. So here we go. We have the price of the item minus rate times amount right here. You see it again. You always take that percent, write it as a decimal, and multiply it times the price of the item. So the price normally sells for P, and we're going to subtract our discount. If the jeans are originally $31 and we've got a 15% off sale going on, we have the price of the item minus the rate times the amount. This is the discount. The money that you're subtracting is the discount, whereas the 15% is the discount rate. So the regular price minus the discount gives us the sale price. All right? Now, you didn't think you were going to get out the door with just the discounted price, right? We also have to pay taxes. So let's use all the previous information and get that what we're actually going to end up paying. I see a mistake. Hold on. You didn't see that. We'll do that again. Okay. So we have the cost of the jeans minus 15% off is going to give us the sale price, but the tax that we have to pay on the sale price, notice that we're multiplying the 6% times the sale price. They're not going to charge you tax on the original price. You have to pay tax on whatever your discounted price is. So when we add this up, what do we get? The final price at minus the discount plus the sales tax, and that's how much we're going to pay out the door. Okay, now let's leave money behind for a minute and talk about what all of this stuff means in the first place. We always hear percents. This many percent of doctors recommend blah, 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 or that percent of students never crack a book or whatever. So the way you find a percent is you take the part and you divide by the whole. This is going to give us the decimal, right? Because a part is usually less than a whole. Sometimes you do get percents that are above 100, and that's okay. It just 200% would be double what you started with. 500% would be 5 times what you started with. 150% means that you took what you started with and you added half of that, right? Because it's 100% and 50%. So what you're going to do is you're going to take the part, divide by the whole, that gives you a decimal value, and then before you put the symbol on it, you're going to have to multiply by 100. So let's say we had 52 out of 300 students. So we say the part, oh, I didn't change that. Sorry, hold the phone. No. I didn't want a never-ending decimal. So let's say we've got 52 out of 400 students are a part of some organization or whatever. So the part divided by the whole, this is going to give us a decimal value, then we're going to multiply that by 100. So when we divide, we get 0.13. We're going to move that decimal 2 places, and we get 13%. So 13% of students are a part of blah, blah, blah. Okay? Now, here's where I want to warn you. Percent increase and decrease are used, say, in the news or in a political campaign or in an advertisement that are trying to convince you of something. Sometimes it's appropriate and sometimes it is not, okay? So if you started with a particular amount and then you went up or down from that particular amount, your percent increase if you went up, decrease if you went down, is going to be the difference in the two values divided by where you were when you started. Okay, so it's not the second value that really matters, it's the starting point. So you're going to subtract the two values to get the difference. Did I go up or down? It doesn't matter. You're either going to call it an increase or a decrease. So this is a positive number. Just find the difference, divide by where you started with, and then you make it a percent by multiplying by 100. So let's say we had 11.5 increase to 18.2. Well, we're going to subtract these two values, and that gives me 6,700. But we started at 11.5, so that's what we're going to divide by. So once we divide these values and we move our decimal 2 places, we get 58.26%. So and this is not the percent of the whole. In this problem, we didn't even know. This could have been out of 100,000. It could have been out of 10 million. We don't know. It could have been out of 20,000, and in that case it would have been a very big deal what we did. But if it was out of 20 million, it's not that big of a deal. So when you are faced with someone trying to convince you with something using percent increase or percent decrease, you got to watch out. For example, let's say that you started out with 300,000 to begin with, and you had the number of sick people in that 300,000 group went from 15 people to 21 people. Well, if you find this percent increase, you're going to find the difference and get 6. Dividing that by what you started with is going to give you 0.4, which is a 40% increase in the number of sick people. That sounds really horrible, right? That there was a 40% increase. But if you think about it, you started out with 15 out of 300,000 that were sick. That's 0.005% of the total population. Okay? Then when you increase to 21 out of 300,000, you increased to 0.007%. Still pretty negligible when you're looking at it in terms of the entire population. So someone who's trying to convince you to be scared, for instance, will tell you there was a 40% increase in the number of sick. But if you look at the actual values, you went up 0.002% when you're looking at the entire population. So pay attention to the circumstances and always ask yourself, is this really a significant value when you compare it to the entire population? Okay? All right, the homework for this section is 1 through 49 odd. And remember, you can always text me and ask me for help. And if you need to jump on Zoom and get some serious one-on-one whiteboard time face-to-face with me, then go for it. I'm available almost all the time for you guys. That's why I'm here. Okay? So, text me, don't email me. Email me is too slow. You got to text me. All the information is in all the hundreds of emails and Blackboard announcements that I've sent. I look forward to hearing from you guys.